Here we go. Oh, and this is the first I've drawn with the pen. The pen is working. My favorite student is good old Ann Serkey. Two masses are suspended. Remember, we called this an Atwood machine, a massless, frictionless pulley with string with no mass. Wants me to find the magnitude of the acceleration. So the way I'm going to do this for any complicated force question is I'm going to label my forces. I could do a completely separate free body diagram, but Kyle, since they gave me such a lovely picture, heck, I'll do the diagram right on here. What are the forces acting on the 1 kilogram mass? Gravity down. I'll call that mass 1, M1G. Is it in free fall, Noah? Say no. So there must be a force up. Who remembers what we call the force pointing up from a rope? Tension. M2G. Tension. Then I asked, who's winning? Now this one, you just have to reason, hey, who's winning? The heavier mass. I'm hoping you know enough instinctive physics to figure that one out. So anything that ends up pointing down on the right-hand side is going to be winner plus. Anything that ends up pointing up on the right-hand side is going to be loser minus. So I have M2G winner plus, and I have minus tension. And again, you might think that this tension, because it's pointing up, is going to be a loser. But if you follow it, when it gets to this side, which way will it be pointing? Down. So it's a winner plus. And that M1G ends up being a loser minus. Oscar, do I have more than one mass on the left side of this equation? Is there an M2 that I wrote? Is there an M2 that I wrote? Is there an M1 that I wrote? Do I have more than one mass on the left side of the equation? Then I better have more than one mass on the right side of the equation. Oh, I don't know where anything is anymore. Okay, it's there now. Lunk. There. Ah. Why am I so relaxed? I'm losing tension. Always relax when I lose tension. Noah, what's this question asking me to find? Oh, how would I get the A by itself? There it is on the right-hand side. What else is next to it? That bracket. How can I move that bracket over? Divide. So it's going to be, stick in red, Mr. Dueck. A is going to be M2G minus M1G. That just drops down like a domino. All divided by M1 plus M2. It's going to be 3 times 9.8 minus 1 times 9.8 divided by, boy, that's terrible, divided by 1 plus 3. Can I do this in my head? It's going to be 19.6 divided by 4.9? Yeah. I did do that in my head. Meters per second squared. Okay. I would probably make this question here worth 2 marks. And you'll notice I have 1, 2, 3, 4 steps. Probably a half mark for each step. But if you got the right answer, Kyle, if you got the 4.9, I give you 2 out of 2. Make sure you have the units. And then I would go half mark for each of those. If you got the wrong answer, I start reading backwards. What that means, again, because we haven't written that many tests because we had our late start and got interrupted by a bunch of stuff, but now the tests and units are going to be shorter and faster. What that means is if you just write down an answer, you better make sure you're right. Show some work. That's your safety net. Number 2, what's the mass? Ugh. Well, I think I'm going to start out free body diagram. What are the forces acting on mass M? Get the obvious one. And I'm going to call this M1 since there's 2 masses. Is M1 sinking into the ground like quicksand? Is it flying into the air like Superman? Well, then there must be a force pointing up. We call that the normal force. What else is acting on this mass? Is there a rope? Well, then we got tension. pulling it to the right. Is there friction, and how do I know? Why? It says frictionless, and in the diagram it says mu equals 0. Now, if there was friction, okay, I'd have something pointing that way. I could deal with it, but nah. What are the forces acting on mass 2? Get the obvious one. You with me so far? What do they want us to find? Little m, mass 1 is what I've called it. Okay. Well, let's write an equation for mass 1. Vertically, everything's balanced in mass 1. Normal force equals m1g. But, folks, what's the force pulling mass 1 to the right? Who's winning? Tension. For mass 1, an equation would be tension equals m1a. Why didn't you put both masses? Because I only looked at the forces for one mass. I guess that means that m1 is going to be tension divided by a. Did they tell me the acceleration? Yeah. Did they tell me the tension? No. So, Max, even though this question says find m1, you know what I'm going to spend most of my time finding? Tension. Tension. How? Let's go write an equation for the second mass, for mass 2. Looking at mass 2, who's winning? Who's losing? I'm going to plus that to that side and minus that to that side. So I'm going to get m2g minus m2a equals tension. Is that okay, Oscar? Now, remember I said even though this question has said find m1, I need to find tension. Let's double check. Can I find tension? Did they tell me mass 2? Yep. 9.8. Did they tell me mass 2? You already said yeah. Did they tell me A? That's why I had to give you that. If I hadn't given you that in the question, then this is impossible to solve. But now I can say it's going to be 5 times 9.8 minus 5 times 2.6. That equals the tension. The tension is going to be, all right, first time I've tried this. Let's see if it works. Maybe. Okay. Let's try this again. Okay. Let's try this one. It's going to be 5 times 9.8 minus 5 times 2.6. Oh, 36. And now I'm going to plug that in way over there. It's going to be 36 divided by 2.6. Mass 1 is going to be 13.8. 14 kilograms. If you said that, I'll go 13.8 kilograms. How many got that okay? A couple of you. That's a tough question, finding a mass. Okay? If I made this one worth 2 marks, I would probably go something like this. I would certainly give you a half mark if I saw that equation. I would give you a half mark if I saw that equation. I would give you a half mark if you found the tension. And I would give you a half mark if you found the mass. And then I would turn the page. Number 3 is going to be the same idea. It's going to be the same idea. So, I'm going to say to myself, tension, no friction because of the wheels this time. Who's winning? Tension. Who's losing? M1A. Sorry, no loser. Winner minus no loser equals M1A. M1 equals tension divided by A. You know what? I think this looks exactly the same as what we had here. Tension equals M1A. M1 equals tension over A. So what are we going to do now? Go look at mass 2. M2G tension. Who's winning? M2G. Tension is losing. That equals M2A. Again, I'm going to plus that there, minus that there. It's going to be M2G minus M2A equals tension. M2, 2.2 times 9.8 minus 2.2 times 3. That equals tension. How big is the tension? It's going to be 2.2 times 6. I don't know. $14.96. Now, I don't want to round this off because I'm going to be using this over here. Mass 1 is going to be 14.96 divided by A. They told me that. 3. It's going to be this divided by 3. 4.99. If you said 5, that's fine as well. Almost exactly 5 kilograms. Again, finding the mass, Ange, that's a tough question. I would give you half mark for that, half mark for that, half mark for that, and a half mark for the answer. So, number 2, number 3, meh. Number 4 and number 5, I like. Totally fair game on your test. Okay. Thomas, my friend, what does number 4 want me to find?
Tension.
How am I going to do that? I think you know what I'm going to do to start out? Yeah, absolutely. Although since they gave me the picture, I'll just label the picture. Thomas, what are the forces acting on this 4 kilogram? Get the obvious one. Well, you know what? I'll do the free body diagram here just to make a point. What are the forces acting on it? Get the obvious one. What else? Would tension be bigger or smaller than gravity if I was drawing the arrows to scale? How do you know? Nice. So if I did ask you for the free body diagram, I just gave you a hint. I might be looking for something like that. Okay? So who's winning? Because, by the way, because when I do these, you'll notice I'm kind of sloppy. I just get the arrows in the right direction, but I really don't put lengths on the tension one because I just kind of slap it on the rope any old place, right? Winning, gravity, losing, tension, and that equals MA. Oh, it wants us to find tension. I've done this dance before. Plus that there, minus that there. It's going to be MG minus MA equals tension. It's going to be M for G 9.8 minus M for A 3 equals tension. Do this one in your head, Mr. Okay. You know what? I can factor out a 4. It's going to be 4 times 6.8. Well, 2 times 6.8 would be 13.6 times 2, 27.2? No? Yeah? Units. Newtons, it's a force. Probably half mark for that, half mark for that, half mark for that, and half mark for that. There's your 2. Is that okay, Kyle? You're looking very puzzled. You're good? I like number 5, I like number 5, I like number 5. Number 5 is the next question. What do they want me to find in number 5? What do they want me to find here? Tension. I can't. Not yet. I have to find something else first. The acceleration. That's why on the earlier ones I gave you the acceleration and let you find tension even though you didn't know mass. Here, if I know both masses, so I'm going to write an equation for both masses, solve for acceleration, and then once I know the acceleration, I'm going to go solve for tension. It's going to be, change colors, it's going to be M1G, tension, M2G, tension. Who's winning? I'll tell you, the bigger mass. I went fast there. So I said, okay, M1G is winning. The first tension is losing. The second tension, though, Cam, when you follow it all the way around, ends up winning. And then, M2G, when you follow it all the way around, ends up pointing up, losing. And then, Oscar, did I write more than one mass on the left-hand side? Yeah, then I better have more than one mass on the right-hand side. Ah. I love it when I lose tension. Yeah?
You put M1G twice.
I put M1G twice?
Yep.
Kind of like right there, you're saying? Candy for you, Thomas, for calling it out.
Kyle actually put it out, said it.
He
He deserves the candy.
deserves the candy? Okay, Kyle, let me get you your candy for catching me in a mistake. So, Kyle, I cancel out tension, right, kiddo? Hey, how would I get the A by itself? So if I hear you correctly, it's going to be the M1G minus the M2, like you said. G drops down. And you're saying I would divide that by M1 plus M2? Yeah. In fact, I can then say the acceleration is going to be 5.1 times 9.8 minus 2.4 times 9.8, all divided by 5.1 plus 2.4.
Dude, this one in your head.
Yeah, this one's yucky. Or is it? Yeah. Bracket. 5.1 times 9.8, take away 2.4 times 9.8. Close bracket, all divided by bracket 5.1 plus 2.4. I have more than one number in the top, better put it in brackets. I have more than one number in the bottom, better put it in brackets. Did you get an acceleration of 3.528? People are nodding. Now I'm not done. Because that's not what this question wanted me to find. What did this question want me to find? Tension. How do I find tension? Go look at one mass. Which one? Doesn't matter. Although I'm going to pick the one where tension is the winner. So Kyle, it's a winner in mass 2. Because mass 2 is accelerating up. So I'm going to go tension minus M2G equals M2A. Mr. Dueck, why didn't you include mass 1 on the other? Well, I'm only writing an equation for one mass now. That was my decision. Tension is going to be M2A plus M2G. It's going to end up being M2, 2.4, A, 3.528, plus 2.4 times 9.8. It's going to end up being 2.4 times 3.528 plus 2.4 times 9.8. you get, I guess 32, because I was going to round it to 31.9, but there's an 8 next to the 9. So I would probably make this question worth 4 marks. I would probably give you 1 mark if I saw that. I would give you 1 mark for the acceleration. I would give you 1 mark for that. And I would give you 1 mark for the tension.